Alrighty. Here we go. Let's see how this rolls. I am Chris from Airwindows, and we're doing another coding stream on the heels of me following up and some commentary on my Console 7 post, where I've been seeing some discussion. So we might talk a little bit about that before starting to code, but it's also given me an idea for something that might be worth doing with the coding. And it might be a bit of a derail from what I've been doing, but that's fine. It's like whatever. We will do the level best that we can. So firstly, I'm already over into coding zone. And let's switch things over to where I can see who's here and what's going on. I think I'll also I always like to pause the little stream in YouTube Studio so it doesn't distract me. So hey, again, like I said in the plugin video for Dark Noise, I have been beating myself into the ground trying to shovel myself out from under a blizzard. And oh hey, Lorenzo. Hi. So I'm a little down for the count at the moment. And what that means is I'm going to continue to do my thing. But I'm not positive that I'm going to be cranking in all cylinders for the next couple of weeks or so. Because it was pretty strenuous. Hey, Felipe. So what I'm going to do now is fiddle with this stuff and figure out what I'm proposing to do for today's coding stream, because I should be able to put in a couple of hours and talk people through things and answer questions as I usually do. The chat is up on the stream, as you can see. David, hey. Oh, by the way, David, I'm getting closer and closer to being able to move on the DIY synth thing. It's just that stuff like that gets derailed by plugins. It gets derailed by me having to shovel myself out from under a blizzard, all that kind of stuff. Like, if I have to put in too many hours throwing snow over the height of my head just to get to my car, it usually means I don't have the energy to do serious coding work or indeed soldering work that day. Although I've done some things, like you might be able to see, or you might not, in the little postcard stamp thing on the screen, that one of my bases is slightly different. And the reason for that is it had two pickups. So I've never liked that, having two pickups. I'd rather it was one of the original Mustangs that only had the one. But I realized I went to the trouble of setting up my Rickenbacker, which I'm still delighted to have. It's amazing, to do Ricco sound, essentially. It's using its volume and tone pots and things. But the neck pickup is going to the ring output of a stereo jack, and the bridge pickup is going to the bridge pickup output of a stereo jack. And when I hook it up, which I've done for the jams and things, which I've been getting made fun of, by the way, on the post, but do whatever. I'm running that bass into a DI for the lows and a guitar amp for the highs. Thing is, it doesn't have to be only a Rickenbacker to be able to do that with. So what I did was I wired the pickups directly to a output jack. Very simple, quick thing. I didn't end up with the knobs and stuff, and certainly not the switch, because the switch is now irrelevant. But now the Mustang, here, maybe I can even reach it. And my monitoring is that little speaker which leans over where I can get to the ATEM Mini, so blah, blah, blah. So I did this. And now this pickup goes to the ring. This pickup goes to the bridge. If I plug this into the same thing that I've been plugging the Rickenbacker into, I get the same result of this is going to a DI with a bunch of bass added to it. And this is going to a guitar amp, which is set up as clean as possible. And it should do the same thing as the Rick did, but in a different way. And since it's a Mustang, it's easier to play. I'm not snowed in anymore, but it took all week to get myself out. And I have tried very hard to not get sick as a result of being snowed in, because I had to go outside in like 0 temperature weather all the time. So I was trying to space it out to the best of my ability, and I was trying to take a zinc when I started to get stuffed up and feel really ill, and it seems to have mostly worked. I do expect that my general health is going to be a little shaky over the next week or so, but I do have some things that I could look into regarding coding and such, and here's part of it. I think maybe I'll put preponderant aside. Yeah, let's save that. Now, what I was going to do today was do the adapting of one of the reverbs to VST so I'd have it to post next Sunday. But something's come up that might be better to do because it's topical. It's relevant to discussion that's happening right now, whereas nobody's really been talking about the reverbs, and so that might not be anywhere near as relevant. So here's the thing. Also, from what people were talking about, they were talking about tracking at 44.1K, or I would recommend 48K for this, and then rendering their mixes at 192, or I would recommend 96, for the purpose of getting less aliasing. And honestly, it seems as if that might actually work. It would depend. Like, what you do to test that out is put something like bright ambience, which doesn't scale to sample rate, onto the one of the channels, just somewhere in the mix. And what you're doing is, since you're doing all of your tracking at 44.1 or 48K, everything is going to be fixed at that level, and you're also doing recordings at the lower sample rate, but that should still be enough. And then logically, if you switch the sample rate over, and this might work differently for all different DAWs, so I can't swear to this being a smart idea, but if you did your tracking always at the lower sample rate, that should still give you enough to work with. It's like direct capture at even 44.1K at a high enough quality of converter is pretty damn workable. Like the filtering that does a certain amount of ultrasonic filtering, but more or less you can get away with it. It's the processing that's the problem. And then if you switched over to, say, 96, which I would recommend for the mix down, assuming you couldn't just record at 96, because I think that would still be better. Snow throw, yep. A neighbor actually had that and helped me get through the plowed in section of really heavy snow. It's just that we got well over a foot, and I was trying to shovel my way back to my car, and I had parked it where I wanted firewood left the next firewood delivery that comes. That's way far back. So I had like 30 feet of extremely deep snow, some of which came off of the roof of the house. And a snowblower that can handle Vermont winters is more like $1,000. I'm nowhere near getting something like that. And if I had $1,000, I would need to go and get one of the new Macs so that I could start working with it. So that ain't happening. It's gonna be me shoveling for a while now. Getting into the Apple Silicon thing is going to take precedence over shoveling snow more easily. That's just my world. I'm wishing like hell I didn't get the iMac Pro when I got it, though that was a little while ago. That was before they announced any of this stuff. So I feel a little bit suckered by them, but yeah. That's Apple as usual. And honestly, one would rather they did things like that than just never do quantum leaps beyond what they had. It's like when the iMac Mini came out, which is another thing I got into at the time, that was more powerful than their existing Mac Pro on single core things. And that was still an Intel device, but they came up with a Mac Mini that was then this sort of platinum color one. And if you were stuck on only single core stuff and weren't doing any multi-core things, that was more powerful than the most powerful Mac Pro they had for like isolated particular tasks. And yeah, David, if you do get the used 2015 MacBook Pro, I will still be compiling for that always. That does not change, so that just makes my life a little bit more complicated. But I will not stop coding for legacy stuff that is perfectly and absolutely workable. Felipe, do whatever you like with that. Thing is, acceleration should be handling stuff like that in its own way. And secondly, if you're oversampling, you're defeating the purpose of how acceleration even works. I'm not sure that it would understand things anymore. You can try it. I mean, you can try it and see if it works. It does function kind of like a compressor limiter type of thing. You can try it and see, because that is a legitimate possibility of one of the things that might work well with some ultrasonic filtering in there. I had thought at the time that it was itself a form of doing that, but that's not to say that it can't throw. You got to be careful with like observing aliasing and things, because if you say try to observe aliasing in AD clip 7 or clip only, you'll get some really weird results because it's doing strange nonlinear things that are not specifically aliasing. And thus, if you throw test tones and stuff at it, you'll get results that are not representative of what it will do on audio. So be careful about acceleration and trying to test it with things like test tones or whatever. Getting aliasing out of that and going, oh, I better fix that with oversampling, because it might be working with the audio in a different way. And what you're seeing is a behavior that it has that applies to audio content and is more a little weird as far as test tone content and things like that. That might be what you're doing, and it might not. Maybe you're just hearing the sound of that, and if so, I don't know, it could be a revisit. Right now, I'm looking at revisiting something that I should probably start to grapple with here. I'm going to go back into this, because here's what happened this morning just before I started streaming. I was on the Console 7 thread over at Gislet's, and been getting a certain amount of static on that thread. And oh, you were okay. So Acceleration is going to be weird with high frequency tones. Acceleration is about handling transients, not continuous tones. So you're going to get some funny reactions out of it. It wasn't really designed to limit, like if you're getting a result out of a tone, you probably have that tone at too high of an amplitude already relative to what you do with a mix. It's designed to, oh hey, slow brain. If you're writing VSTs, you can't be that slow of a brain. I don't know if it's possible to write VSTs with C#. I know I'm not doing it. What I'm writing VSTs with is C++ because that is what it is coded in. The framework for it is not only C++, but like back when I was talking to my brother pre-COVID, his take on it was like, wow, this is old school bad C++. It's like lame C++. So I don't know if you can write, like, that would depend upon like whether you could adapt the framework, the VST framework, to something like C# and have it actually do anything. So I don't know. And gamma, the one that averages the rate of change to the rate of change of the voltage, would be more like surge or surge tide, I think. I don't remember exactly. Well, I can look at it. Let's go and look at what ultrasonics is doing. Back to AU, not ultrasonic, but acceleration. A, not U. What am I talking about? It's the first thing on the list. Let's have a look at that while we're at it. So here's what I had, two simple parameters, both of them are generic. I've got these things. I think acceleration is working kind of like DS. And there are things like, I don't think you could get functional results out of DS if you oversampled it. It's trying to track changes between samples, so if you smooth that, you're just making it harder for the poor thing to work. Since acceleration is, yeah, this business with Sense L and O3 and whatever, this is like the DS code. This is trying to track the difference between samples, and then it's trying to track the difference. It's keeping a list of several successive samples and the differences between them. And it's looking for instances where one sample is abruptly higher and the next sample is lower, that you've got a little tick in there, which is reversing direction rapidly. If you oversample that, you just have a sort of hill, and it's way harder to keep track of. Whereas acceleration is really looking for transients and doesn't understand the concept of what a sine wave is. Sine wave is its worst case scenario. You might do better to feed it a square wave. And as you can see, it's a very small plugin. Look, this is all it is. We got a dry wet and a intensity control, and this is all acceleration is. So because of that, and we seem, we're having a sense control be, let's see, what do we got here? Like, this is our entire audio code right here. So we're keeping our list of samples. Smooth L appears to be how loud all of our samples are divided by 3. And acceleration is supposed to be like an acceleration limiter in vinyl mastering. There's a version of that in, I think, 2-vinyl. But acceleration is that just split out of 2-vinyl. And what we're doing here, like bit by bit. This is making a list of samples. This is making an average of all these samples. As you can see, that's what that is doing. It's the one we're on, the last one, and then the one before that. These are keeping track of, let's see if I can select this properly, doing the best I can with it. This is like S1 minus S2 or S2 minus S3, and it's altered a little bit because it's that multiplied by the same thing over again. It's just the same calculation divided by 1.3. So you can say this is a sort of variation on, because it's always going to be smaller, on just S1 minus S2. And what you get if, like, it's a big positive waveform, the one minus the other is going to be like 0. If it's a big negative waveform, something negative minus something else negative also goes to 0. So this is making stuff smaller. And if there's just differences between each of the samples, then one's going to be different from the other. You subtract them, you're sort of moving them down to 0, and then there's still a value there. It could be positive or negative depending upon which direction the sample moved relative to the other one. If you multiply that by itself, you're making it smaller by the factor of how small it is already. It's like running a power function on a input value to make it act logarithmic, where, like, they're going to be between -1 and 1. Or they're going to be between negative anything and anything, but as you sample, in both VST and in the audio unit, you know, Core audio and whatever, when you sample stuff, clipping is usually 1 or -1. And then if you square it, it's always going to become smaller if it's smaller than 1. So if you have a control and it goes 0 to 1, and you want 0.5 to actually be a much smaller number so that it gets way bigger as it goes to 1, then you'd multiply it by itself. So 1 times 1 equals 1. That's always going to be the same largeness. But then 0.5 times 0.5 now becomes 0.25. There's more subtlety of adjustment around the beginning of the control. Like you have to push it over to about 2/3 or so to get to 0.5 as an output. And if you did power of something higher, like you did something power of 5, then it's doing it over and over again. It's going start at 0.5 times 0.5 times 0.5 times 0. You get a very small number, and it will still go to 1 at the extreme end of the thing. That's what this M1L and M2L are doing, is it's tracking the difference between two samples. And then when it's multiplying it by itself, scaled down a little bit, what it's going to do is, if it's a very large number, it will stay relatively high. In fact, it could get extremely high if it's larger than 1, like if you cranked it up. But if it's a tiny value, it's going to become a ridiculously tiny value. And this is how acceleration doesn't change the tone very aggressively if it's not kicking in good and hard. Now, sense L is the absolute value, so it's always going to be 0 to something positive, of M1L minus M2L. So think about this like this. I'm actually showing the screen, so I might as well leave the code showing. Look at my little tiny postage stamp thing in the corner here. If you got samples, here's a sample, here's a sample, here's a sample. They're going like in a direction. Say you got a triangle wave. So your samples are going up. M1L is going to be this minus this. M2L is going to be this minus this. They're going in the same direction. So M1 and M2 are going to be the same thing. That means they're sort of on a slope. what you get out of sense L when you do that is fabs M1L minus M2L. So we had M1L being the difference between these two samples, goes down to 0, so it's like this much, positive. And then M2L is the same thing between these two, goes down to 0, and then it's still positive. They end up being the same number. And this minus this equals nothing. So sense L is not simply, it will work even better or more aggressively at 44.1 K. Well done. Exactly. Nailed it. So that's why this one does not want to be oversampled, as you can probably plainly see. It. I think it will, actually no, it won't scale, will it? Let's look. Overall scale. So our intensity number does get affected by this. I tried to make it adapt, but it's still going to have a harder time doing it, because your window of what you're looking at is getting smaller as well as the intensity between samples. So what happens if we're at the top of a triangle wave? We're going continuously up like this, and then we're going down from that point, and the middle sample is the point at the top of the triangle wave. Now we have a set of samples that look like this. So the difference between this one, it becomes, we'll call it a negative one, negative something, going down from the top of the peak. This one is positive one. It's going up to the top of the peak. These three samples are at the peak of the triangle wave. So M1L becomes a negative something very small. M2L is a positive something very small. Sense L becomes absolute. In other words, it becomes positive once you're finished working with it. Negative 1 minus positive 1, you get 2. So sense L is showing how much, not only how much difference we have between like a flow of samples and then one that's suddenly out of, well, it wouldn't matter. Either one, if they're different rather than being on a continuous line. Well, here's the thing is, actually, you might have a very good point there. I think what's happening is, yeah, here, you're looking at the screen anyhow, so this is the same as, I didn't realize I was doing that, but that is what's doing it, is if we're doing a negative number and it's times the negative number, then it does make it positive. So I'm saving myself the trouble of doing an absolute on there. So M1L is actually never, this could be a really interesting point. We might be able to improve this algorithm through these observations, because it seemed pretty straightforward to me. But yeah, or we could make it be this, at which point we have what I thought I was talking about, where one of them could be positive, one of them could be negative. And then M1 minus M2, we do have that distinction. So I think that's a relevant observation, might be worth re-looking into. And as such, you get something where it can read. See, I think what's going on there is it's a minor detail, but probably still worth doing. I'm going to go and grab one of my note cards. I've been writing down things to observe here. I'll use this one. Acceleration I'm writing the relevant bit of code. And we'll see whether I remember that in among all the other things I'm doing. So yeah, well spotted. That does change what it does. If you're doing coding, this is the kind of thing that you'll need to do as well. And you could say that one got past me, although you could also say it just changes the algorithm. It changes what it will do under certain circumstances. There's other circumstances where it'll be just fine. And you don't need to be concerned about the fact that you can't have negative values out of those. But like if you have one of them positive, one of them negative, and it's that minus the other one, then send-cell goes high. If they're the same thing, then they become 0. And if one of them is basically 0 because it's a flat line of samples, and then suddenly there's a big departure, it's definitely going to go high, regardless of whether it's on M1 or M2 that it's doing it. It'll do it in 2 successive samples. And then sense L is scaled by the parameter intensity. Intensity is how hard it does it. And then what we're doing here, this is a whole separate part. Which is not necessary, but it's part of the acceleration sound. And it's keeping a list of 3 different senses on the output of this. And we're using only the loudest of the last 3. Intensity is the user input, yes. Intensity is this, which is parameter 1, 0 to 1. It's to the power of 3 so that it's more logarithmic. And then it's multiplied by 32. In other words, it'll become higher. Divided by overall scale, meaning it'll become even higher at high sample rates. Overall scale is 1 if you're at 44.1K. And if you're at a higher number, it'll become like 2 for 88.2K. So intensity is something big. Intensity means sense-L can be made very large. Now, this little bit here just makes sense be the loudest of the last 3 instances of it. It's a compressy type thing. You wouldn't need to do sine to convert it back into something. And the reason that matters is because we could smooth off the points of triangle waves, no matter how steep they are, by remembering the sign of the value with this change that I just made, which I'll probably have to leave out so that we have some consistency, and then I'll go back in and update it when I put out I can put out another acceleration. Maybe I can even filter the output of it, because it will generate some. It's a good question as to the usefulness of pre-filtering into this one when it's trying to track differences in sample entirely. But you could filter after, and that might be relevant. Anywho, this gives you the compressy type quality where it's going to sense and then store its maximum reaction for a little while. If the maximum reaction is larger than 1, then we leave it as 1. And this, you might recognize as the same thing as this. This is input sample, and this is something I like to also adjust, is dry sample 1 minus wet. There's a number of things that I would change in this that I would probably want to build into a new plugin that does a variety of things along these lines. These are things that I would change that I was doing a while back. It does keep it nice and simple looking, but this is actually arranged the way that I would do it in the dry-wet control now. And this is input sample times 1 minus sense. So if sense is maxed out, this makes input sample be 0. It's a dry-wet control between the raw output and the smoothed output, because as you can see, the very next thing is input sample plus equals smooth times sense L. And smooth, of course, is the average over 3 samples, which is in itself a funny kind of thing, because averaging over 3 samples has its own characteristic. Averaging over 3 samples gives you some of those little notches. So, and they're going to be slightly different for what it, so we're using an averaging filter rather than trying to do like a biquad and really accurately deliver a filter that cuts highs. That also means that it's going to act differently at high sample rates, because averaging over 3 samples at 192K is very different from averaging over 3 samples at 44.1. So yeah, we've got some things that we could re-examine in here. In specific, this smooth factor really should be adjusting to adapt to higher sample rates better. I think this is one that really would rather run at 44.1K. So there's that. And then we're dividing sense by 2, so it can only be a maximum of 0.5, which apparently is because, well, that's, we're, ATA last out is actually just what we're doing with A averaging on our output. That's all that is. So accumulator sample, I would be renaming some of these things as well, and I'd be declaring them where they're being used rather than declaring them up here. I've learned since the time that I coded this one. Although one thing about it is kind of nice and small and tidy the way I had it, but I would definitely do this real differently now. We can... Do you want to do this instead? Guys, who's those who are listening or watching, do you want to do this instead of what I was going to do? I didn't start doing the thing that I was going to do, and I'm finding all this stuff now that I would do to re-examine this. It's seeming like a very obvious call that I need to put out an Acceleration2. And there's a variety of stuff that really would fall into place here. What I was going to do, some of the folks who show up at these would be really excited about, but maybe that can just, it'll happen. Okay. Because you're following this, that's why. You're following this, and therefore it would make sense to do this with it. So the thing that I was going to do was related to the talk I've been having on the console 7 thread. Namely, a fellow was going, please watch this video by Dan Worrell, please, 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 because he explains why you should oversample instead of running at a higher sampling rate and why running at a higher sampling rate is bad. And I finally went and looked at this, and Dan's wrong. Dan Worrell's conclusions were wrong. The things he were doing was right. The sound he was getting was right. But there was nothing he was doing that couldn't be done by putting an instance of ultrasonic, mine or Tokyo Dawn's, between his cascaded distortion stages in his mix. Dan was wrong. He was not correct that you're better off doing lower sample rates and oversampling between things. And so I mentioned this, and I said this is why his guitar tone is working better, is because it's nothing but a set of digital distortions, and you have to filter between the stages of the distortion, much like if you are running console 7 Cascade, which does exactly that. And you could just do that. And it has nothing to do with oversampling being better. It's really not. It's that he's applying a brick wall filter because of the oversampling between every distortion stage. That's all that's helping. And it makes the distortion stages not as good as they might be, because they're running in the individual things within the oversampling. Actually, hang on. No, that's not true. They're running at a higher sample rate, but it's not the oversampling that's helping him. What you need to do is run some ultrasonic filtering between your cascaded distortion stages, exactly like it's being done in Console 7 Cascade. And I went, oh, would it help if I did a guitar amp plugin that was based off of Console 7 Cascade, which should be hiding here? But instead of using the Console 7 gain stage, which is really expensive with double sine factor and stuff, instead I could use like Drive and more stages, and instead of being low passes, I could use band passes. And I even came up with a name for it that I can do. And we'd be building the, I could use the same 5 biquads, but instead of arranging them this way, I could set their resonant frequencies to be adjustable and the frequencies to be adjustable. And maybe even use some of them. Like I could throw more rather than just the 5. I could do more because each stage won't be as expensive because it won't be the Console 7 distortion stage. And just build it out of just cascading a huge number of things. And at the end, I could throw a bandpass that was a lower frequency, so you'd have some distorting that would fill in your lows a little bit, and you could have like a lows, mid, highs thing going on, where it would be like tone controls, but all the input stages would be just cascaded into each other. Well, that's the thing is, oversampling every plugin in a chain, there's also latency to consider. And I don't think like phase shift is part of analog filtering. So when you're modeling things like physical amplifiers, physical guitar amplifiers are built with a form of filtering that has phase shifting. The roll-offs that you get on primitive RC filters are not phase linear. So yeah, don't get thrown by too much technical talk, especially when it gets down to digital things. So I can say this is on the agenda. Ahmed, thanks to the conversation going on in the Console 7 thing, especially if people go nuts over that and like, oh my God, yes, give us that, you'll see this happen. However, the acceleration thing is driving me a bit nuts at the moment. Actually, hang on. Let's bring this back because I have some of my filters in there. Oh wait, did we not open the project? We just opened a file. I have filters in here that I can use. Yeah, they are in fact Butterworth filters. That doesn't mean they have that flat of a phase response, but they're reasonably flat. Like the way they're arranged is a little unusual. They're arranged in that cascade where the initial step is a very high Q, and the way it's arranged, they even themselves out. But we're applying distortion factors at places in the calculation where it's an intermediate calculation with funny peaks and dips, and that's giving it its sound to some extent. So let's see, here's our acceleration. I won't need to build here, but what I want to do is let's call this Acceleration2. Doesn't need to be stereo. it'll be one of our incrementing numbers of things. And I will start adapting this over. People make fun of you for copy pasting stuff a lot, but I find that it can be relevant. SL is its name, huh? We're going to call this one is M because the last digit is going one more. I have not looked at Swanky Amp. Oh, by the way, Andy, one of the things I've been doing over the last week is I tried putting some of my Minecraft stuff back together. I'm still not sure what to do about it. If several of you folks want to just come and hang out building blocks, I'm not sure if I'd be down with streaming that. But I can perhaps make that a thing. Well, Butterworth is defined by 60p per octave, so yeah. If you stacked them, you could get steeper filters, and maybe that departs from being phase neutral. Oh, there you go. Okay, so that is what you're saying, in fact, that only one stage of Butterworth is phase neutral. Start stacking them up, and you start getting more into phase shifts, which I think implies that you have some phase shift in the passband anyhow, because it'll start sneaking in there. Anyways, Acceleration2's ID will be ACEM, ACEM, because it's one more than ACEL, which is the name of acceleration. That's how I do my naming conventions for those, seeing as I generate so many of the buggers. So our desire, here's our, I might rename some of these while I'm at it. It was 2018 that I did this. That's like forever ago. That was back when you could go out into the street and talk to people and hug them. Oh, I'm going to depress myself. Let me stop. Boop. So there's our limit in dry wet. We probably don't have anything here to note. Our tail time and latency is still 0. And this stuff gets used. I don't even know what decel meant. Is that even in there? But boop. And the first thing we're going to do is get this to be the same as it was before, and then vary on it. It's a little like refactoring. Oh, huh. Fair enough. I bet I can probably make an amp sim that sounds better for some things, but it will depend, it'll be a matter of taste, really. So let's see, 2 parameters. The rest of these are blacked out because they no longer have relevant data. This was 0 to 1 for both of those constants, so both of those parameters run, and that's the same as in VST, so I like leaving it that way. I could say parameter unit logarithmic, and it would show differently on some, but not all, audio unit hosts. Much less interested in doing that now that Apple is no longer honoring being an audio unit host when they invented the format. So what are you going to do? And then lastly, here's a place where we define some of these variables. And see where it says FPD 17? The new way of doing this is to have FPD become a random number, because we're only doing that once. So we can do it here. It's not that expensive, and it'll give us better randomness in our dither values, and it'll also give us a unique random number for every single plugin that we're running, as long as it's doing this. So we can use that in multiple places, as long as we don't mind it being the same random number for the dither, but also for whatever we're using inside the plugin. And then final thing before closing this out is we'll just start from uint32 and sample frames, which is a unsigned integer, all the way down to nothing there anymore. I'm going to have a quick glance and see whether this is looking... Oh, okay. See, this is an older version of this code. Static cast fpd times 5.9, whereas this is the up-to-date version of the code. So yeah, Acceleration is getting a number of improvements here. And we start from unsigned integer 32 and replace all of this, including the older... Oh, wait, hang on, slow down. Slow your rolls, honey. Let's do that differently. We like the one that came with the template here. We don't want to change that part because the previous version wasn't best. It was not the correct one. So what we're going to do instead is a little bit more detailed. This up to the while, which is still a bit of a waste because there's a bunch of stuff here we're simply not going to use. Boop. And then the dry sample area to the dither. This is what we do in VSD sometimes as well, is copy the stuff that's not part of the framework. That way the framework can be updated. There's our dry sample area down to the dither. So now what we have is exactly the same as Acceleration, but slightly updated, and we're not going to save that. It probably won't build right away, and sure enough, it's not building right away because the way this works, it kind of needs to do its compiling to have some of its intermediate stuff in place. I should be able to do it again, and it'll be fine. Kind of fine. We've got some mistakes in here that we're going to look at. So, in this version of Xcode, one thing I can do is click on this and it'll go to the place. And in fact, the reason this is here is because we've defined another instance of this that we're now using inside the loop. It's inside this bracket. So if you tell it to be a new one, you've got this one here. Technically, I think what you could do is long double input sample equals 1, and then you've got this while loop. It goes while this, then it does this, defines another one, at which point it's ignoring this one, using the one that it has inside itself. And then once you're finished, outside of this, if you went print input sample, you'd get 1, and it would ignore this, because it'd be looking at the one that was made outside. But that's just confusion waiting to happen, so we don't want any of that, so we remove it. Now let's see. So one of the things we're also going to do is bring some bipod filtering into here. I feel as if that is a very relevant concept. And we can do it using one of the we can define what we think is a good place to do it. Because I see 2 places for a biquad. One of them is to replace this smooth thing. I no longer like the idea of doing smooth with only average. I would prefer doing smooth by running a biquad filter just to generate a nice little sort of Butterworth filtered thing where it's rolling off the highs starting at something like, I don't know, 3K, 5K? It could go even lower. It could be like rolling the highs off starting with like 200 hertz if you really wanted to, but that would be relatively useless. And then the other biquad sits after all of this, because if you're generating aliasing out of the very thing itself, you're going to want to take out those supersonic things that are generated by it. So let's see, I want to get rid of this ATA last out and call it, and I don't really need it to be called L either. That's from the stereo. So those are changed, and that's the only place it's being used. This is apparently not scope. I don't really get that part, but it doesn't change the stuff in reset. And then lastly, I need to go over to the header file. H is for header. I can put the R and L in the VST version. In fact, let's take all these dumb L's out. Why do I even have des? What is des? Where is des? Am I even updating it? Yes, apparently I am, but am I using it anywhere? Let's find out. Also, sometimes I use A to Z for this stuff rather than 1s and 2s. But for this, I chose that for some reason, so we're going to stick with that for the time being. I don't see it. I don't see des. Let's take it out and see if the program dies. Maybe it's from DS. Can we still build? Nope, because we need to update all this other stuff. Okay, so let's go through that. We didn't update all of this. Yeah, so here's your problem. Let's make this all go out. Why is it not complaining about this either? Oh well. Only be a moment. Excuse me. Like I said, this week has beat me up physically. I like you thinking, David. Let me see what I get out of that. Firstly, let's also constrain that a little bit. This is as far as this needs to go. Let's see. Okay, I'm scanning over and seeing whether David is a brilliant fellow who has saved me a bunch of trouble. Do I see any L's that are not the things I'm literally just deleting? Because that's what I'm watching for. I don't want to, if I was trying to remove P, I would be breaking stuff up here. If I was trying to remove S, it would change other things. Is, however, any... No. Nope. David, you are made of wind. Here's what we can do. Find and replace with absolutely nothing and keep it with in selection. Option in this version of Xcode gives you in selection. But thank you, David Pixley. I don't know why I didn't immediately start doing that, but whatever. Succeeded. Okay. We could simply test this. Maybe that'd be a good idea. Let's go from here. Here's our Acceleration2. Go into the build folder and into release because I've got it set up to release. Components. And let's see whether we can get a sound out of this. What would be good? I'll just throw dragons in there. That has some bright noises. Chrome Dragon has some very bright noises. So firstly, acceleration sounds like this. Dark, bright. So that is, and this is at 44.1K, it makes it easier to hear it. So that is definitely capable of softening things. Now let's see whether Acceleration2 also works. Here we go, it looks the same. Right. To quite dark. Alrighty, proof of concept. It does work. Well, here's the thing, is I intend to use a biquad Butterworth filter to make the darker sound, because if I do that, I can have consistent behavior across multiple sample rates. And then I'm going to use another biquad in ultrasonic mode to just roll off the result of the thing. And then we're going to see whether the behavior of the algorithm works the same at different sample rates. And I know how to do that too, because I have alien kittens in 44, 96, and 192 ready to fool with. That's how I'm testing some of these things. So you'll be hearing alien kittens pretty soon. But for now, let us do some of these updates that we were doing. That's how we do a wet dry. What else do we have? We were going to yeah, this is, that's actually the new code for that. I'm not sure when I put that in, but and this is the code that we'd be, no, that's not. This is the code that we'd be replacing with a biquad in order to get our filtered output. That also happens. Not only that, I'm not convinced that we really need to see where I'm freezing up here is how is all this implemented? This is where we are applying the filtration. So we're changing it between raw input sample and the three-stage thing. This is the part that I want to replace with the biquad. This is also doing the same thing, but it is filtering after our processing. So it's applying there's a 3-sample average, and then there's a 2-sample average. They're both tied to sense. And this last sample and accumulator sample is also part of this code. But that's still just an average. Whereas we could be connecting to the filtered one according to how much acceleration there is, and then do the ultrasonic filtering regardless, rather than fading between the two. Because all this averaging stuff doesn't scale. All this averaging stuff is going to give us different results at different sample rates, and I no longer want that. So essentially, This is the thing that you can do in C. The asterisk and slash are areas of commenting stuff out. I'll be leaving this alone. I've probably got about another hour of this before I have to go lie down. This is our dry wet. We're leaving that. We'll be getting rid of that. And replacing it with something else, which will be smooth becomes the filtered version. Now we're keeping S3, S2, S1, and so on because that's how we're tracking what happens. In fact, let's do some silly things. Let's experiment. We like doing that, right? We now have a smooth value of 0. So we'll have output that is like normal. We're no longer smoothing that part either. But as we start triggering sense, it starts cutting out entirely. Let's listen to this. This is the kind of thing you can do. And our complaint is you didn't use a cumulative sample. That's true, I didn't. In fact, a fair bit of, here's some other things I could do. I know that's sampled out. I could technically have just deleted that. Look how small this is now. We're just doing our overall scale, and then the only thing we're actually paying attention to up where the controls are is intensity. You could probably, I have code that uses averages and just stacks them up more at higher sample rates. That's in the alternate version of console 7 that I did before I did the... So I do have code for doing that. I just didn't like it very much and I found it cumbersome. And one of the problems with averaging is it winds up with this very slow roll off. Rather than having a point where it starts to filter, it's like, no, off we go. So you stack up averaging filters and it can be very nice in some ways, but also very unpleasant in others. You have to really like the tone that that generates. Now, that does also mean that averaging filter would be not totally bad as far as this is concerned. That'd be an acceptable way to get smooth. But for now, let us show this. And we'll go to Alien Kittens this time. So here's how to break a plugin. And let's use this to test something else too. Acceleration2. Instead of just softening the sound, when it cuts in, the bits that you hear, the hats and stuff, that would be affected by the softening effect are instead just being straight up assigned to 0. And the blending between them is the sense factor. So this is showing you what it's doing in the most aggressive possible way. Now let's see what it does at 192K, because I have a version of Alien Kittens that is at 192K. And at 192K, it can't tell anything is happening at all. In fact, let's test it at 96K. I think it may also not be able to tell anything is happening at all. So this is something we can work on immediately. Yeah, it can only function at 44.1K the way it's set up, because it can't tell anything is happening at all. And I have some ideas as to why that would be happening too. Firstly, let's scale this differently. Instead of making this factor become slightly smaller, if I remove the divided by 1.3, all of this stuff is going to kick in harder. Then if I increase everything by overall scale, that means that our numbers can be larger here. And that means that there will be more of a thing, and sense will be able to go higher. Because sense is tied to intensity, it gets affected by overall scale. Actually, this is weird. Why is intensity smaller for a larger overall scale? It's times 32, but divided by, that makes no sense. Let's see whether we can make it super act here. We're going to change that and have this other stuff. My brother used to make such fun of me for doing things like this, but I might get a faster reaction out of it. We will see, because I can tell that's wrong. It shouldn't be a smaller amount at the higher level. It will do what it was in fact just doing, namely diddly squat at high sample rates. Now we've got it cranked up so that it might kick in way, way easier, or arbitrarily easily. Let's find out what it does. Okay. Now there's an important factor here, which is this is making smaller bits of audio being cut out, because it's at 192K, but it's only tracking 3 samples in a row. So that's doing about the same amount. But for this one, you can plainly hear it's a different texture. And we don't want that. We would like it to be the same texture, really. The challenge here is that we have a texture that's made up by cutting out or smoothing, because eventually it will become smoothing the two together. And rather than being reduced to 0, we're going to be doing a crossfade into a filtered version, and the filtered version will be at a particular sample frequency so that it will be consistent. But we're not getting that here. What we're getting is it's much darker. It's kicking in over a wider space and time, because 3 samples cover more time at 44.1K than they do at 192K. So you see it's kind of dark and crunchy. And 192K, or if anybody was insane and did it at even higher sample rates, you can get roughly the same amount, but it doesn't sound the same because it's not covering the same range. We need to get it into that zone where it's a little darker sounding. I don't want it to be this different. So one possibility is to just keep a wider set of samples. Yeah, what we're getting here is definitely, like I'll increase it even more. Let's exaggerate this so that I can really hear what the hell it's doing. That's our maximum intensity. It seems to be at about the right amounts. Can we do a averaging filter or a width? Well, see, here's the thing is I am a little bit puzzled by this. We could simply space them differently. This is something that I did with bus colors when I was adapting that, since that is straight up just and this is one of the problems that stops me doing the cabs plugin, because that was always kind of bad, but it was also just an impulse response and it was at one sample rate. Bus colors ended up getting adapted to where the things in it were being spaced out, stretched as if it was a pitch shift at higher sample rates. And I could do that here because all I really need to care about is whether, yeah, like let's do this. We're going to assume full wet at all times. And so you see where I'm going with this? Oh, hey, Brick. Yeah, happy holidays to you. See where I'm going with this? These are spaced by exactly one sample apart. But if I space them much more widely, that would be different. So one thing I might think of doing here, since we are dealing with large numbers of these, is let's just call this something else. Let's call this and the other ones don't have to be scaled in the same way because we're still using 3 points of measurement. But yeah, spacing out the samples based on sample rate should work. Not only that, I should be able to fiddle with it so that I can get other behaviors out of that, which might be better than what I was expecting. So that's the thing. And this doesn't need to be 64 possible things because let me go and find something where I'm using a buffer. Or maybe, is this a good place? No, that's just how I'm doing interpolated delay buffers. I don't have a good place for delay buffers here. I gotta go and get it from somewhere else. Delay buffers, show me the code. What's a good place to get the code? Let's go and find one. I start sounding more like a gibbering lunatic who's also sick the harder I work at this stuff. Let's see. So let's find something with a delay buffer. Here's one, bright ambience, which does not adapt to sample rates. But what it does do is it declares a thing like this. And then see, that's one less. We can make that just go away. We're using S. So rather than S1, S2, and S3, we're going to be like S count. Let's go back into here. I get caught up by these off by one errors a lot. So what I do is just try to make it a little larger than I actually am going to need, because what I don't want is to have it trying to access value 64, but it's really counting from 0 to 63, and it's a random. That's a good way in C to have like weird sketchy errors and problems, is doing stuff that doesn't really belong in the memory space you've allocated. Where's C++? Here it is. So now we have assigned this. Their sample, so this should be 0.0. Did I tell it to be? Yeah, it's float 64. Oh, God. So, spacing is going to be this. This is now going to be a delay buffer. And these things get calculated on the fly. So we're not going to use any of this stuff that says S1 or S2, but I can make a little change in here. Oh, not that way though. For now, which will just show me, even though this isn't legitimate information, that I'm going to be wanting to work with array variables, because that's how I'm doing that. So the way this works, you can do a silly thing. And I'm going to do that for now, just for simplicity's sake. When we get larger numbers, it starts to become too silly to do. I'm going to show you what the silly thing is now. And with this, we have just done nothing, but see how it says S2, it says S1. So with this, we have now just incremented everything. Actually, what we should do is do it the opposite way. It won't work properly this way. Here's the opposite way, where for in count starts at 63, because we're going to be using one more of that, and count is larger to or equal to 0. Use this, and then once you've done that check and run whatever is inside it, if it was true, then subtract. So if it's equal to 0, we use it as 0, check to see if the thing is true. Actually, we're not worried about whether it's true or not, because this is just a for loop. So every time we go through this, we do it like this, and then we subtract afterwards. If the subtracts were in front, you'd have to minus it. And here's the true or false part. We're asking if that is still true, or we're breaking out of the loop and stopping. So if count is -1, that no longer counts, and so we stop. If it is 0, we do this thing and then increment it. I'm pretty sure that's how this is working. Anyhow, this is how it's been working. C is twitchy sometimes. It's complicated and confusing. So we are incrementing all these things. We could have had if we had a whole pile of stuff like this, it would be the same as this. So if we do S0 equals input sample, now what's puzzling me now is, why am I only looking at S1? I bet I know. Oh, there's a bunch of stuff going on in here. Check this out. I didn't notice this at first. M1 is S1 minus S2 times the amount of same thing. M2 is S2 minus S3 times 1 and 2 again. I didn't spot that at first. See, these are not the same. These are different. Now, do I want them to be different? Do I want them to be scaled in this way? I don't think so. I think I'd like to have these be unique to each other. And since I was counting things from like 1, 2, and 3, and since arrays are started with 0, we're going to use the array. We're going to count it down to 0. We're going to do all of this kind of stuff. As you can see up here, we're also initializing it starting at 0. So S0 will also be assigned to 0. We are going to adapt this to the same principle, namely 0 minus 1, 0 minus 1, and for now, let's see if we have it the same. So 1 minus 2, and then we go back to this original one. We now have a much wider range to compare with, but we're not using any of it. Instead, what we're doing is we're still making smooth be 0, and we want to hear exactly the same thing that we heard the first time. We shouldn't have changed the sound at all doing this. And yeah, unused variable spacing, yeah, I knew that. I figured that part out. Let's find out how true that is. I'll try it at 44 and 192. Do we still have that sort of dark sound? I think I increased it somehow. It feels like this is the, maybe it's because I've changed the amount to all the way up to here. Let's see. Was this because I just made that 64? The last time I tried it was at 32. Let's find out. Because I knew I bumped that up at some point. Oh, I changed this. That's what did it. Okay, so never mind. We'll leave that stuff. I'll accept it as a change because I changed this too. And that is going to alter how all this works, but let's see where we've got so far. See, this doesn't worry me. That's one of the things that would bother my brother when he was trying to do this stuff with me, is I change stuff on the fly really fast because some part of my brain is keeping track of all of this and able to track it. I can often not figure out stuff that my brother Dan can figure out, but I can also often pursue a bunch of stuff like that. Oh, I can have both of them open at the same time. Handy. And I feel like this is starting to work. Even though we're not spacing out the samples at all. So this is a finer grained effect, whereas this is a coarser grained effect. Which I feel is plain to hear. And dry wet is not being used. Let us now make this change, because we started to get into the ballpark. Again, like I said, I'm not worried about having all things changing around at all times, because I feel confident in my ability to narrow down what's happening. It doesn't always work that way, but that's one of the ways I function with this. Is my way of doing it is definitely a stew. Change everything all at once, get to somewhere interesting. This is what we're doing right now. Is these m values are being scaled by overall scale, and I'm having each of the sides of the 3 points that we're measuring being independently scaled. They're not tied to the first one. They're both equal, and then sense is the absolute value of the one minus the other. And they can both be positive or negative. And if they both match, we wind up with nothing. So it seems good. This is our averaging factor, which is also something of a concern. But I'll worry about that later. This would also need to scale. But one thing I can do, let's see what happens if I do this. So I've just, I've not changed the spacing at all, but I've stopped it averaging that. So it's now using whatever value there is only of that particular instant. It's not trying to smear it across 3 different, let's see what it sounds like. And again, this is not softening, this is only assigning anything here to 0 if it triggers. It's making the scrunchy noise, but the scrunchy noise is easier to hear. So 44.1K. Sort of crackly noise. 192K should be finer, but it might not be that much of a difference because we're taking away, yeah. It's acting a little bit like I'm solving the problem. That's sounding very similar to what it sounded like before. Almost like if I went to a filtered thing, these two would sound the same now. That'd be interesting. So let's roll with that. I liked that. That means we no longer need O3, and I can take that away from all of this stuff now. That's another very Chris from Airwindows thing, is if I feel like I'm on to something with this, I'm like, cool, okay, yeah, axe all of that stuff, get rid of it. Usually if you're doing something like GitHub where you have source control, you can do that all you want and then just revert it. I do have source control, but not on this machine because it's too old to run modern versions of like GitHub thing. Granted, I could run that in terminal, but I find terminal Git to be obnoxious. So yeah, now we've taken out an entire smoothing factor that we were previously using. Now, let us see, because we're certainly not going to be using that, so let's just leave that out. Here is, in fact, I can smoosh those together on one line just for the hell of it, because this is a dumb primitive thing, and if it turns out that I want to use a really tightly knit little area, I might very well handle this differently so that it's such a small little loop that there's no reason not to do it this way. What would happen if you had like a sample buffer of like previous samples, which is what this is. This is like every sample is one, it's like a bucket brigade thing, like a bucket brigade delay. One over and then put the new one in, and then one over and put the new one in. It's a delay line. And normally what you do is make it as a big sort of ring buffer, and then rather than moving everything over one, what you do is you go, okay, I'm here, I'm going this direction, and the thing that I'm trying to check, which was like a few samples ago, is this minus however much. So you're moving this direction and you're going, okay, I'm looking at here, and both of those positions move. And then as you are like at the edge of the buffer, you have to calculate and go, am I wrapping it around over here? That's another thing that you do. But if you only have like 4 or so of the samples, there's no reason to do that. It's easier to just move everything over one and add the new one in. And we might very well find that this is going to end up our spacing has to be at least 1. So now we have a spacing that can go up to 10, but starts off as at least 1 and scales. They're multiplied by each other, meaning that no matter what I hit, like if I have a spacing of 10 at like 48K, if I went to 96K, logically it would need to be twice as many, and that's what it would become, because overall scale would be 2x that. So now we have a number of spacing that is relevant. And it's always easier to calculate stuff than to move stuff around in memory. So we're going to calculate some of these things. We're going to go S0 minus S spacing. What are you doing, menu? I didn't ask for you. Why is it doing that? Foolish thing. And 2 is, of course, spacing times 2. And as you can see, I also remember I need to do this. Menu, go away. I didn't ask for you. I don't want you. Now this produces arbitrary width of spacing for our little thing. And if we went up to a spacing of like 32, it would start going beyond the bounds of the array, and that wouldn't work any longer. Like if I do S, large number, C will let you do that. Unfortunately, you get garbage. C lets you read that, but nobody knows what it is because it's in RAM somewhere. It has nothing to do with your array anymore. And if you write to that, you have big problems because you're stomping all over somebody else's memory value that wasn't yours and doesn't make any sense. So we're going to go back to that. That's just never do that. And now we have a control that's sitting on our dry wet control at the moment. By the way, I am looking to getting we're in use. That's because Twisted Wave is open. I am looking to find a value that I like to keep rather than having that be user adjustable. We'll see. That's the very kind of thing where people are like, oh my God, I want to do the thing where I can set it to 32 and then have this effect. I'm like, oh no, this is for a purpose. But let us see what we get. Here's Alien Kittens at 44.1K with our new control. 0 is smallest effect plus 1. So this becomes the same as we had before. Clean. But as I start increasing this, we're going to get more aggressive of a reaction. Sounds like crap. That's a very edgy sound. I know, right? It already sounds kind of like Nicola. Now here's the real question. I can make it do horrible things by setting it poorly that way, but is it going to do exactly the same horrible things at 192K? Let's find out. Not exactly. I'm getting an exaggerated response. Like this is at 0.1, but it's not dissimilar to what I was getting off a very high setting here. So we are getting too much of a reaction out of this now. Why is that? Because we no longer need overall scale in this equation. See this? This was adapting to the spacing being only one sample and that being different at high sample rates. But now we're just exacerbating it enormously. We can simply take out this scaling here. Boop. And boop. And with this, we have a far higher chance of having it behave the way it's supposed to. What we were doing is exaggerating it enormously. And since we were already spacing it out, like using this spacing calculation, whatever we settle on is already going to be the same distance along the, like if the spacing is the same spacing in time, the distance that it covers in voltage is going to be the same regardless. We don't need to also multiply it by overall scale to make it work. So let's now see whether we have it being exactly the same at different sample rates. Let's open all the variations. If it can, it can. So here is our, that's nasty, but dialing my ear in to hear this. 192K, is it going to be the same? No, it's not. That's way quieter. But if I scaled it back, see how that was about a quarter as much? And this would be about a half as much if my theory is correct. Okay, so something's still up with this. I have, oh, and I bet I know what it is. See how I have my intensity control in here? This is also scaling by overall scale. What I've done is essentially remove the need to scale any of these parameters by overall scale at all, ever. If the spacing between points at which I'm measuring is the distinction between that, nothing else ever needs to be changed by overall scale. So what I've got up here, you can just go away now. We can keep the large effect, or we could even dial that back. I don't know. Let's dial it back just because I'm getting such a strong result. Spacing is covering everything now. I still think that's going to be set to a fixed number, but the number that it produces is going to be the number that updates everything. And then I can like calculate it out at 384K or something silly and go, that is my maximum size, because this little thing here won't necessarily need to be 64 big, but if I need more and more space in it, the higher the sample rate is. So I can make a limit to how big spacing can possibly be. Yeah, forgot to shut off twisted wave again. There we go. Meh. Don't hide the... Thank you. Anytime I'm not really very physically well and I'm a bit beat up, I get crankier. Let's see now. Here's my two instances of my track. Now let's see if they sound exactly the same. Memorize that squonk, and what have we got at 192? Exactly the same squonk? Oh my god, no. Super different. But is this because I'm trying to do something terribly wrong with my spacing? I got NAN here, I got other stuff. Maybe I'm just trying to set spacing to some number that's too high? What do we get if I am using a different setting? Like I'm at 192, so... Getting into that obnoxious noise. And then let's open this up again and see if it's giving me the same one. I think what's happening is I'm smashing the buffer. Basically, the way I've got this set, go away, twisted wave. Like the reason it sounded different wasn't because the algorithm is different. The reason it sounded different was because this is giving me a setting. Yeah, see, 1 times 10. Overall scale run at, yeah, here's what happened. Follow this math with me. 1 full crank times 10 equals 10 times overall scale from 44.1K to 192K. That would be 192 divided by 44.1. That's a factor of 4.35, 4.35374. So I have 10 times 10 is spacing becomes 43. So M1 equals S0 minus S43. That works. M2 is S43 minus S87. But our buffer only goes up to 63. So the way this is set up, I can dial it in to a place where I moved that control all the way up, and the whole thing broke not because the algorithm was wrong or wasn't working. It broke because the algorithm was trying to read garbage data that wasn't in the array. The array only goes up to 64. It was trying to do stuff with a whole bunch of different stuff, and so everything broke. The solution is like not to do that. So I'm probably going to want this in future. This is just shows you what might happen. Do we actually have a... No, we don't. We're going to top that out at 31 instead. There. Now if I build this, and I copy it over, and then I run, say, Alien Kittens 192, or if I upsampled it to 384K or whatever. Now if I do it, this works, but it doesn't die when I go all the way to here. It doesn't sound right. It changed, but previously if I did this, it would kind of pop, and then one of the channels was out completely and the other channel was saying not a number. And yeah, this is debugging. This is sanity checking. Now what I'm also wondering is, how are we doing as far as these kicking in consistently? So let's go fire up this one again and start experimenting with this, seeing as we can hear when it kicks in because it's setting everything to 0. So if I set it to this, that snare is giving me some action. Actually, wait a minute. So we're hearing that at full limit. And then at the 44.1K, it will sound the same. Not super different. And then this is our intensity. So now what I'm asking is, what's a good setting? And this is something we can start doing here, maybe get a nice useful result. What counts as a good place to start doing this? Because this is acceleration. This is not about nuking the mid-range or anything. I should be able to do this with a relatively small number of samples and scale down the whole loop a little bit so everything will be a little more efficient. But what I'm trying to do is approximate a calculation where the initial way of doing it was like one sample apart. 3 spaces, 1 sample apart each. I'm probably going to want to make that be a little bit bigger in a way that still sounds correct at 192 when they're all about like 4 samples apart. But I don't want to make it sound like that they're all widely spaced. It still needs to be high frequency oriented because this is acceleration. By the way, I can't tell whether anybody is still, whether you're just listening or whatever. I've got 10 viewers still, but I can't tell whether last thing I saw was run that through ULaw with Nicola in between and then everything died. So I seem to still be streaming. Seems fine. I guess it's just either that interesting or I've gone over everybody's head. We've got a few minutes left. Let's see what we can get out of this. Sure. Okay, we're here. So 1. That's probably going to be 2. I'm listening for the distinctions. Either that or this is 2. So like 1, 2, that's probably 3. That's already too much. And then more and more. So I'm going to be talking about something a little short of 3, certainly. Between 0.1 and I think 2 is my maximum at 44.1K, which means when we translate this to this one, it'll have more granularity. And I'm trying to dial in a number that works. Let's skip ahead to the So with this, it's going to go into that zone more gradually because they have more samples between everything. And 1 is too little, and 2 is probably too much. It's starting to sound like the type of zone I'd want to get into. Too little. Probably too much. I think I can probably work with this. I think that's going to be a good consistent factor because, well, let's load up some of these other ones. Open them. So we got this at 192K. Good and crunchy. At 96K, that becomes this. Again, 0.173. Same sort of boxy tone. I'm getting something out of it. And then at the lower sample rate, I think we're 2. Yeah, that works. So that sounds fairly consistent. So I'm going to copy that number. This is what we call spacing. So that means that becomes 1.73. Times over all scale plus 1. And that gets us a consistent factor among various different things. So let's just do a little quick calculation. 384K divided by, hang on, 34K divided by 44.1K is a factor of 8.7. So 8.7 times 1.73 equals 15 plus 1 equals 16. So if we went all the way up to 384K, 16 is the max we would expect to see in terms of spacing. That means that if I say spacing larger than 16, that means spacing times 2 is a maximum of 32. And I'll do my usual little leaving a little space in case anything I worked it out wrong. So now we have a smaller array that'll still handle really high sample rates because we're using this one set amount. And that means that instantiating it is less, but also our little calculation in here is going to run quicker because we're just shifting fewer of these over, even at very high sample rates. Not only that, we can get a little clever here. Overall scale. And I'm going to definitely test this to see whether it breaks everything. I don't have to do this. I don't have to start at 32 necessarily. So I'm going to want 32 if I am at, let's see, what was it, 384? 8. So technically, if I do overall scale times 4, hang on. It might be better to work from spacing, honestly. So yeah, 384K needs to cover a range of 32. 1.73 times, it was a factor of 8. That's about 13. Absolute max 16. Oh yeah, 13, 14. Absolute max 16. Therefore, I need to do twice spacing. So I can start at spacing times 2 for absolute max. So if I do this, then at my highest possible rate, I'm using the entire little buffer. But, pulse. Do I know any good plugins that make sounds watery with chorus? I had some stuff like that. What the heck was the name of that one? Let's go into Xcode and start scrolling through projects, and I'll tell you. I know I had something like that. Watery and washy and spacey and stuff. Dang it, I knew I had something in here. What was the name of that one where I had multiple delay taps that all moved around independently? Maybe I have it on my desktop. I had one. I know I had one. Yeah, melt. Don't I have... that's something I did, right? Like I did release a plugin called Melt. Yeah, didn't I release a plugin called Melt? Yeah, it's Melt/Tape Wobble because I was going to change it into something else. Yeah, if I do have a plugin called Melt, try that one. That does it in a really big way. Let's get back to this while we're at it. I've just set count to be spacing times 2. What that means is I may be instantiating a larger array, but since everything just gets moved over, if I'm running at a higher sample rate, I shouldn't have to move all like 64 or 32 spaces. I should move only a few. Let's see if it worked. Build and analyze. No, I don't want you to analyze. I don't know what even that means. Do not analyze. No, stop. Build and Analyze is the name of a podcast with somebody who I forget. And I don't know whether it's any good. Let's quickly sanity check this with the 3 alien kitten settings. Yeah, that would work. I could see how that would work. All right, so Acceleration2, 44.1K. Do we still work? Yep. Do we still work at 192K? Yep, it may sound very similar. Do we still work at 96K? Yes, we do. Okay. Gotta remember to quit out of Twisted Wave again. Cool. Nailed it. Let's put dry wet back. Alrighty. Now we've got acceleration that adapts to all sample rates and responds sanely and intelligently to them all. But we're still setting smooth to be 0. So we have 2 things to do that are fairly, like it's already after 1. I'm feeling pretty tired, but I think I can probably do these things. What I'll do is I'll go and grab a plugin that has a couple of filters in it already. We'll look at console bus and maybe just rename it. Oh, no, we're using A and B. That should be fine. So what we're now doing is we're using this window to go into here and set up our biquads. We'll make some space for them to go. We'll go here. And initialize them. I don't know why I didn't have a space after that. And we'll do some stuff in here. But first we'll just take it as is. So this goes before the while, this goes before the processing. Stop that. Breakpoint. I don't really know how to use breakpoints, nor do I like them. I like just running stuff and observing what it does. So now we have 2 low passes defined, and they are both 20K. They're both filters, and they're both set to these amounts that are part of the previous calculation. That's not actually what we want. What we want is out of somewhere else, but we're going to forget that for the moment and put these into the code. So we can set up the filtered one first, I think. And this is the other one. And the rest of this is part of the processing, doesn't actually count for this. And then the other one goes after everything, replacing this code, which was just averaging. It's a fine place to put it. Now we can leave input sample here. This does our processing. This changes input sample. So this is going to be straight up filter. this is actually a pre-filtering, which we don't want. What we want here is to do all of this, get our end result, but then make something else be here. Namely, this is where we put smooth. We're not touching input sample. We're leaving that the way it is, but we're making smooth be the output of this. And then we're still using the, I think, hang on. I don't know if that's necessarily so. Here, this is the series of samples being done by this, but I think this needs to be smooth, because this is like the post filter delay loop. So yeah. Yep, I think that's how that works. These are the ones that get updated by just the raw sample coming in. These are the ones that get updated by the output. If I have that be input sample again, it'll break the biquad. So, if this is correct, I will have now changed this to where it will work, but you won't be able to hear any difference at all. Let's find if that's true. Components, replace. If we do this, we're switching between no effect yeah, it's kicking in, but it's not doing anything. And that is because all of these filterings are at 20K. And we wanted to do something else. So I think back to the removing the wet control again. And biquad A is the one that we want to be, here, let's do this a little bit differently. B is the 20K. A is something else. What else? Let's find out. Also, it's a little weird that it's divided by cat sample rate, but not really, because this is the guts of the biquad filter. Times bug, remove semicolon. Now this goes biquad A, which is our smooth here, is 20K times get parameter k param 2. We're going to dial in an effect that sounds like the acceleration filter, that sounds like that averaging thing that we had, but it will adapt itself to higher sample rates, and it'll be a nicer sounding filter, clearer sounding filter than just using averages and trying to do it that way. And it still has to be divided by a get sample rate, because that's how you make the biquad work. Also, these don't need to be these numbers. Ideally, what I would want here is to be using Butterworth. So I can look that up. Maybe I've got it in one of the biquads. Let's go and find out. Let's look in biquad and see whether it gives me those numbers. I think it might be one of my defaults. Ah, sure enough, I got it written down. Resonance 0.7071 is Butterworth. I would like to use Butterworth for this, and so we're going to copy that. Close it up. I could have looked it up in a book just as easily. And these only get to be different values like this if they're serving the same purpose and they're a cascaded filter. Those two values were what would work with the console channel plugin also having its own filter, but that was 1.6, etc., etc. The big part of the golden ratio. And the combination of that, the 0.618 and the 0.5, give you a Butterworth made out of 3 poles. But these are two different values. These are not the same. These are, one of them is straight up roll off, and one of them is a much lower roll off that we're about to dial in the amount. So we want both of them to be actual Butterworth roll off, actual 0.7071. And boom, let's see what we get. And now we have all the things we were doing before, including the limit cutting in, but at full crank. This is a 20K filter, and then as I bring it down, it starts rolling off more and more and turning into the previous one. And if I took it to 0, it would probably crash. I don't think you can put 0 in a biquad filter that way. So, here we go. Right. And 0.5 is going to be about 10K. And about 5K. Except for I'm not really sure that is. I also do think that this is too low. So full bright. Or here's a crazy thought. We could have it lean a little harder on the rolling off associated with the limit control. It could work. Does it sound reasonable? That you start pushing more limit and it starts also dropping the pitch at which it's doing its thing? That's the kind of ganging multiple things onto one control that I often find kind of useful. Like this is about as hard as I want to push it. And this is nothing. Here's a hunch. What have we got here? This is kind of too dark. And this is arguably too bright. How's this sound? This sound is 20K times 0.382, which is the inverse of the golden ratio. Of course, it always has to be about the golden ratio, right? Right? Darker. Let's hear what we get on a higher sample rate while we're playing with it. You can often just filter in the damping path of a reverb. I do a lot. Brighter. Okay, so here's the interesting thought. Let's keep hacking. Instead of doing 20k times get parameter param2, so I'm just keeping all my parentheses in a row here. One for there, one for there, and let's go dig out this, see where we get, because that was our maximum, was so now what we've got, if we've not applied much of param1, it's trying to be at 20k. And increasingly, as we push it farther, it goes down towards a maximum of 0.382, namely 1 minus golden ratio. So logically, this should work. Let's find out what it does and how it feels as we move it. It's not a resonant filter, so it's all kind of arbitrary. It's a fairly slow roll-off. All right, low frequency version. Engage. No change here anymore. Bright. Rather dark. Technically, that would drop it from 20k over here at the no effect at all, and to about 7k at the absolute max. And as you start backing it off, it also starts brightening up a tiny bit. So small adjustments become a thing. And yeah, as you start getting it engaged, like down here, we're technically limiting around 10k, but it doesn't feel, well, no, it actually is higher than that, isn't it? It's like 14k. And we start getting darker and darker over here. Let's do one more, well, two more things. One more thing is, let's hear it on 192k. I like the sound of that hat. I think that actually kind of worked. So, what was the other thing? I was going to try it on 192K, and I was going to, what? There was an additional thing I was going to do here. I don't remember what it was. So that's fine. This is still, is it even necessary to have a dry wet on this? It's coming into shape so well that I'm not sure I need a dry wet on this anymore. Why would you have a dry wet on something like this? The one control is the thing that you want to do. You don't want to pull it in even farther and then be like, oh, let's use a little bit of the completely... No. Why? Why would you have a dry wet on this? I'm feeling rebellious. I want to take the dry wet away. No likey, the dry wet. Why? How is it useful for this particular thing? Why would you not just pull it back a tiny bit and everything about it adapts to cover it? This is not supposed to be shelf-like. This isn't an EQ in that kind of way. I don't know, man. I mean, it's easy enough for me to leave it in. Right now, I don't have to do anything. Just do nothing and I have a dry wet. I'm just like, nah, but it's making me mad. Build. There. It's built with the dry wet. What the hell was I meaning to do with it? Both of you want dry wet. Sure, I can leave it in. Not like I have to do anything fancy to leave it in. It's just, it's there. Oh, Francis, don't tell me these things. Nah. It bugs me when I have extra things on the plugins that don't need to be there. What was I going to do? Well, you don't need to be open. There was totes something I was trying to think about, so what was it? I need to go and lie down. Don't tell me these things. There are people who need me to leave it in there. I would get yelled at in KVR if I left it off, honestly. There's a lot of folks like that. So why don't I have an output level control? All of that kind of stuff. Yeah, this is all fine. This is working. I can squish this into a thing. Let's use the same format as this. There, now it's the same format as the dry wet. I'm still stumped figuring out what the hell it was I was trying to do. There was something in there somewhere that I was going to do. Thinking about the way the hi-hat sounded. Let's squish some of this together too. Sometimes I break stuff out into things that are not necessary. There, we can define it. We're using this, but then we're also building this stuff into that from the beginning. This now means nothing and can go away. And again, it's getting smaller and smaller. We've got this biquad stuff being put in, but compared to the original one, this is quite tidy in size. Like between dry and dither, it's this. And this is the first biquad. This is coming up with it. This is working out how much of it. And this is the final biquad. And then a dry wet. So yeah, fairly tidy. Let's do one last test and call it a day. Oh, hello. You need to have a semicolon there. Having done that, that probably will be fine. Or not. What's your problem? I know that it needed to be a semicolon there, but I think we have the wrong number of parentheses. That goes there. That goes there. Extra one. Okay, that was the problem. So we can take that out. Then it's this plus this. I did need to add the semicolon there though. And now we're fine. I gotta quit out of frickin' Twisted Wave though. Oh, I'm getting grumpy again. I need to go and lie down. And 96K the way God intended. Let's hear what that sounds like. Quite substantially darkened. Oh, I remember. This is what I was going to do. This is what I was going to do. Let's look at what it looks like on the screen. So, it's badly sample rate converted, so this is the real output, and this is what you get by the bad conversion. But as we start kicking it in, rolling it way off, and our real high frequency filtering is in fact at 20K. left. Let's do something else too. Where was that damn thing that I made? Dark noise. I'm not going to use it as a dark noise, but bright noise. So this is what it looks like to run white noise through Acceleration2. The whole thing is applying the filtering above 20K, which looks like this. Doesn't really sound any different. But then as it kicks in, that's what it do. So what I'm seeing here is at, let's say 30K, we're going from about, what is that? How many dB down is that? Minus 44 dB down to a maximum of 85 dB down. So you can cut about 40 dB off of supersonics this way. And it's not really affecting the highs that much because it's not supposed to. Yeah, I'm pretty satisfied with where this ended up. Bloop. Okay. I'm going to call that a work day. Sorry for not working on Preponderant or doing the guitar amp thing. But I feel that this was worth doing. It just kind of jumped out. I was like, oh, hey, look at this. Look at all these things that I should probably do. And I think that it did wind up being something better. So now we've got Acceleration2. That might be next week, unless I have something more important to come out next week. But that's Acceleration2. Expect that coming pretty soon. Could be next Sunday even, depending on how it works out. I do not know, sir, whether it's possible to make the noise algorithm that has that type of noise shaping built in. I've done a bunch of them though, so it's like, yeah, I guess we'll see. But no, acceleration is fairly complicated. It's a fairly complicated little thing. And it's doing a de-esser style thing, but it's looking for striking back and forths in the waveform. And yeah, it is apparently a fairly decent acceleration limiter at these things. The one thing I did not do, which might be worth looking at, is the previous, which I did not save, plus the other acceleration, the one that I just improved. We'll see whether or not it did actually improve it or not. So let's find out. Firstly, we need the dark noise again, which we're going to set to be really bright noise. Turn on the speaker. And we're going to want box angle span. And then between these, we're going to add both our acceleration. That is post-span, by the way. And our Acceleration2, which clearly darkens much more than the previous one did. And now let's make span acknowledge that. So, max damping on acceleration is able to do this much at this sample rate. It sits on its chest a little bit. And there's that little nudge in there is because of the 3 sample averaging factor. Whereas Acceleration2, much more effective at high frequency limiting, much more extreme of an effect. And if we run it to like a smaller amount, let's get it to about an equal amount of attenuation at 20K and see what they do. Looking like a little bitty over about 40 dB. So, maybe a tear more. About that much darkening. About that much darkening. We got a spike here at minus 55 compared to a good 65 or so down. And again, it rolls all the way up by the time you're done. And then acceleration can't go any higher than that, but Acceleration2 can go way higher. Alrighty. I'm satisfied. Acceleration2 is better at doing what acceleration is for than the original acceleration. Cool beans. Now clearly I need to put it into the new 2 vinyl, right? Anywho. Because that's the thing, is it was designed as a acceleration limiter for purposes like mastering, where it would be keeping track of those transients that had too much energy and would hurt the cutting head without obviously filtering everything else. So yeah, it is a good measuring tool for certain things. So if you were actually trying to do vinyl mastering, or if you were just trying to make it sound as if you did, Acceleration2 is better at that than the original Acceleration was. It's still pretty much as good at letting through highs and sounding bright and sparkly. But when sort of the rubber hits the road, or especially if you're working at high sample rates, which I didn't test the low sample rate condition there, but I'm most concerned about like 96K and stuff at the moment. It's doing a better job of killing off energy way up there than the original one did. So cool. I am satisfied with the day's work, which turned out to be kind of long, but whatever. Now I just got to make it into a VST and you folks can have it. And with that, I'm going to bid you good day and catch up with you folks at some future time. Fiddle around with my various settings and things. Alrighty, it's been quite a afternoon. Talk to you guys later. Bye-bye.